This UCSD TV program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest programs.
Human babies are really expensive. And I'm not just talking about what we have to pay the midwife or the doctor or the hospital or the birth center, or even the $241,000 that it apparently costs to raise an American middle-class child from birth to age 18 today, or in more universal terms, Hilly Kaplan's figure of 13 million calories. I'm talking here about an expense that our species, our lineage has borne for hundreds of thousands of years, if not millions of years, and that is the expense of gestating, being pregnant with a very rapidly growing, large-bodied, large-brained infant. Human infants are really big, and any of you who have given birth probably know what I'm talking about when I say that. The data suggests that human infants, this is pretty late in pregnancy, are about twice the size of the infants of our closest living relatives. So human babies are about 6% of the mother's body size, and monkeys and apes tend to be about 3% on average of the mother's size. So you can just see from that graphic, to me, that made those figures jump out because it looks like a really big thing. And again, those of you who have been pregnant know what that feels like. For the first 6 months of pregnancy, the first two trimesters, the main thing that's happening is the baby's being made. So the actual organs are being developed. By the end of the 6 months, most of the work of making a baby has occurred, but now it's time, and beginning with the last trimester, to put on weight, to put on fat, to eat as much as you can to give that baby an inordinate amount of fat. In fact, if any of you have looked at baby animals, baby monkeys, baby chimpanzees, and compared them to baby humans, you know that there's a huge difference in just what their little faces look like with fat, chubby cheeks and so on in the human baby. So that last trimester, that's what the green is referring to there. Almost all the energy that the mother's able to consume goes toward putting down fat. And that gives the baby a head start in the first several months of life. The fat also helps the mother with her lactation, with developing the breast milk and so on. But it's a very important time period. So how does a mother get the fat that she needs? She needs, in the last trimester of pregnancy, she needs somewhere between 300 and 500 calories in order, beyond what her body needs, beyond the kind of work that she's doing just to give to her baby. And for most of us, that's a really easy thing to do. In fact, some of you may actually put on 500 calories just during the break today. But for our ancestors, this was not such an easy thing to do. On the right-hand side are the ones that we eat pretty frequently and get our 500 calories. On the left are some of the foods that our ancestors were eating. And most of these are very difficult to obtain. And so any kind of help that the mother can get during pregnancy to help her put down those extra calories. So anybody who can share food with her, members of her social group, her relatives, her partners, her friends and so on, is going to make a difference in her being able to put down that extra fat. She has a couple of things that she can do. She can just eat. And I think this little squirrel kind of illustrates the idea of stuffing your face. And just put on as many calories as possible. But any of us who've stood before a Thanksgiving table laden with wonderful foods knows that you reach a point where you just can't eat anymore. No matter how good it looks, no matter how wonderful it is, you can't eat anymore. And that's what happens to all of us, whether we're pregnant or not. We just reach a point that even if our friends and relatives are bringing tons of food for us, we just can't eat, but we can only eat so much. The other thing thing that they can do, though, is help us out. For a pregnant woman, she's expending a fair number of calories just to keep her body alive. She has to expend the calories for gestating her baby, but she also needs the calories in order to go out and get the food, to gather the resources that she needs to stay alive. And as you can see with this mother, she's carrying a baby, a toddler. It's probably about 2 or 3 years of age. She's carrying a lot on her back. She's working quite a lot. So if her friends can help her reduce her labor so that she can give more of the calories that she's able to consume to the baby that she's gestating, then there is an advantage to that. So she's not going to sit back on the couch and eat bonbons and watch TV, but if they can just reduce that, the amount of her calories that are going to her baby, then that improves the circumstances for her infant. It's also important to get this. I mentioned that the baby's brain is growing quite rapidly at this point too, and in order to get good omega-3 fatty acids and things that are particularly good for the brain, some of the hard-to-get foods, particularly animal protein, that could be provided by her friends and her kin. So this is what I call the first point in the child-rearing cycle, providing some help in the last trimester. This is when the mom it's pretty obvious that she's pregnant at this point, so anybody who can help relieve her burden, provide her with omega-3 fatty acids and so on, there will be an advantage there. So again, the first point of shared child-rearing. But eventually, no matter how much she's eating, she reaches a point where that fast-growing baby with that fast-growing brain essentially outstrips her ability, her metabolic ability to provide those nutrients. And this is what Peter Ellison and others have referred to as the metabolic crossover point. This is the point, the graph I'm trying to show here, the sort of orangish line is the rapidly growing fetus and the nutrient needs that it has, energy needs that it has, and then the mother's ability. Her ability to metabolize gets a little bit better in pregnancy, but it certainly reaches a limit. And according to Ellison's view of things, this is the point where the baby, in his words, begins to starve. The fetus begins to starve, and this is at some aspect at this crossover point. Some trigger actually begins parturition, begins the birth process. It's a good thing that the baby comes out when it does after about 9 months of pregnancy, because if it doesn't come out soon, it's going to run up against the very rigid pelvis that we have. And again, those of you who've given birth or watched someone give birth, you know that it is not an easy process. It is a very tight squeeze. What we have are these large infants with large brains. Most births occur head first. And it is a tight squeeze. And then one further complication that we have beyond that of most other primates that also have a tight squeeze at birth is that our pelvis is adapted to bipedalism, which means that it is twisted in the middle. And I'll talk about that a little bit more in a second. But for most primates, because we are large-brained animals, for most primates it is a tight squeeze. This is a schematic that goes back to Adolf Schultz's work in the 1920s that shows the relative size, the dark circles of the baby's head, the neonate's head, in comparison with the mother's pelvis. And you can see really tight squeezes in everything except the chimpanzee. The chimpanzee's mother is pretty large. Her body's pretty large. Birth is actually pretty easy. The labor contractions are probably just as challenging as they are for us, but the squeeze is not as tight, so it's usually a relatively simple process. But it's a tight squeeze for most of the other primates. So many primates are, and some other animals as well, are at the maximum that their heads can get through the pelvis. But as I mentioned a minute ago, because of bipedalism, our pelvis is twisted in the middle. And I've tried to show this. This is a baboon pelvis on the left and a human pelvis on the right. And you can see that if we can divide the pelvis into the inlet of the birth canal and the exit of the birth canal, you can see that those are going in the same plane for the baboon, and you can see that they are perpendicular to each other in the human. So it's twisted in the middle. And this twist requires a number of compromises as the human is being delivered. In a macaque birth, and this is probably true for most primates, the baby enters the birth canal facing toward the front of its mother's body, and it exits in that same plane without undergoing rotation. And you can see with the little yellow arrow there, you can see the baby's coming out facing in the same direction that the mother is. It has the motor ability to actually help guide itself out of the birth canal, but she reaches back to do so because she's giving birth up on a tree limb there, and if she didn't help the baby out, there'd be some problems with that. She brings the baby up to her breast and begins nursing. With the human, what we have is we have all these dimensions that are not going to give too much. We've got the pelvic inlet, the birth canal inlet, which is widest side to side. The pelvic midplane, right there, at that station, the ischial spines, that's the narrowest point of the birth canal, and that's the point where the baby, which is entered facing side to side, you can see that that is not going to pass through going in that direction. It has to undergo rotation to be able to emerge through the pelvic outlet, which is widest front to back. Now the baby's head has to line up. All these dimensions need to line up pretty well. And the shoulders, if you can just think about our anatomy, the front to back dimension of the head is the greatest dimension, but the shoulders are perpendicular. So we got all kinds of fun things we have to do in order to get born, unless we're going to do a cesarean section. So this is what happens with a human birth. You have a series of rotations. Those of you who are familiar with this drawing may appreciate the fact that we had the mom sitting up in this rather than lying flat on her back, as you often see in obstetric texts. But anyway, the baby enters facing side to side, undergoes rotation, and comes out facing backwards, facing away from the mother. If she's lying flat on her back, it's facing down. But again, I prefer to think of it as an anthropologist facing backwards, because I would prefer to think of the mother in the upright position, which is much more common across cultures. This provides some challenges to the mother at this point. This is a Japanese macaque giving birth to a baby that's facing in the typical direction of the human delivery. This is kind of unusual for Japanese macaque because most of them do come out facing forwards, but in this example the baby was facing backwards. And I think you can see from that how challenging it would be for a bipedal animal to reach back and help to guide the baby. It's not impossible. Women give birth alone all the time. But it's a little bit more challenging, and I would argue that mortality was reduced in our ancestors when she began to seek some form of assistance at birth. So here are some things that having someone present at delivery can do. We're not talking about high-tech obstetrics or even highly skilled midwives. We're just talking about having someone, your mother if you're the one giving birth, your sister, your co-wife, your friend, whatever, or your partner, the father of the baby. They can help to guide the baby out of the birth canal and keep it from falling to the ground. Most babies are born with a lot of fluids around their faces, around their mouths and noses, and if she's in a position to be able to wipe that clean so the baby can start breathing, or so that when it does start breathing, it doesn't suck down those fluids. Also, it can check for the umbilical cord being wrapped around the neck. In a high percentage of births, the umbilical cord is wrapped around the neck, and it's very simple to go in and lift it over and help the baby complete. And perhaps more importantly, perhaps the most important thing in terms of our evolutionary history, it's difficult because the baby is highly undeveloped at birth. The baby doesn't have the motor skills to be able to climb up its mother's body to get to the breast. Granted, we don't have the hair for it to hold on to, but even then it's very difficult for a baby to go up and begin nursing. What has to happen very soon after delivery is that the breast needs to be contacted, preferably by the infant's just nuzzling the breast. And at this point, that shoots oxytocin to the mother's system, which leads to the clamp down. First leads to the birth of the placenta, and then the second contraction usually leads to the clamp down of the uterus. Postpartum hemorrhage occurs in about 10% of births in the world today, and it is the factor that accounts for 35% of maternal mortality at birth. So postpartum hemorrhage has probably always been a problem, partly due to the very, very deep association between the placenta and the uterus in the mother's body. And so anything that would help keep the mother from suffering from postpartum hemorrhage, which if it doesn't kill her, will certainly cause some problems with losing blood and things like that. So these are the kinds of things that a midwife, a birth attendant can do without being terribly, terribly skilled in this. So this is what I call the second point of shared child rearing. This is friends and kin who are present at the delivery to help care for the mother and the baby. There is some evidence, and I'll have to talk to Sue Carter about some of this, but there's evidence that fathers, when they're holding their baby, experience an elevation of oxytocin, which is Sue and others have referred to as the love hormone. But I don't know if this has ever been tested, but I'm willing to bet that family members and friends who are present at a delivery who have some affection or some emotional attachment to the mother and the baby also experience that oxytocin. And if oxytocin leads you to then have more affection, more bonding, there's a lot of anecdotal evidence. I know the bonding literature is controversial to some, but there's a lot of anecdotal evidence that those who are present at a birth, who otherwise have an attachment with the mother and the infant, feel more bonded with the baby and are more likely to provide care and so on. So this might be one of the chemicals that we have that helps us in this caretaking process. The other thing, of course, as I mentioned, is that the baby's brain is quite, even though it's large, it's relatively small at birth compared to what it will be as an adult. This is due to the metabolic limits having been exceeded at about 9 months of gestation, when the baby has only developed about 30% of its what it will have as an adult cranial capacity. So its ability to actually do anything to help itself get born is really quite limited. And a lot of that, then, its survival is dependent on its parents. There are some good things about this, though. We are language animals, so the ability to be exposed to the outside world while the brain is growing in that first 9 months of life would be definitely selectively advantageous. What you're looking at here, this is the first year of life. This is birth, and the sensory, hearing, and vision develop in that first year of life, and a lot of language is developed during that first year of life. The baby's not necessarily speaking, but lots of language. We know that from lots and lots of research. A lot of language learning is taking place in that time period. So there's an advantage, not just a bunch of disadvantages with metabolic limits and a tight pelvis, but there's an advantage to being born before the brain is completed growing, so that that language learning can take place during that time period. So in conclusion, we give birth to very, very expensive and highly dependent infants. There's a first stage, what I call the first stage of child rearing, which is when friends and kin and members of the social group help to provide food for the mother, particularly during the last trimester of pregnancy. And then there's a benefit gained from having friends and kin present at the delivery to help you get through that period, and perhaps to be exposed to the infant so that you're going to continue doing that investment in the infant. One question we might ask is, well, is the baby really totally helpless to help himself at birth? Just look at those pictures. They aren't at all helpless. They are very, very cute, with really chubby cheeks and looking alive, and maybe not quite smiling yet, but at least looking pretty cute to the mom and the dad and some of the other family members. And maybe with a little goose of oxytocin from the people who are observing the delivery. They make us fall in love with them, and then we're willing to invest time and resources, and sometimes even our own lives in raising them from birth until independence. Thank you.
So today I'd like to talk to you about infant state. I'm going to talk about human and chimpanzee infants. We know that human infants have a variety of different states. I wanted to talk both about those things that we think of as physiological states of an individual and those things that we think of as engagement states. So I'm going to talk about both. In the newborn period, we're going to talk about infants, chimpanzee and human infants from birth to about 30 days of age. And in the dyadic engagement states, we're going to talk about infants from 1 week to 4 months. And I really would like to be able to talk about the other things, but I'm not going to today. So the question I'm going to be asking throughout the talk is, what makes us human? Is it something about states? So we're going to be comparing chimpanzee and human infants. And our goal is to actually see if we can identify maybe human unique states, or if the state exists in both chimpanzees or humans, we're going to look to see if there's a human unique level of that state. So we're going to talk about 2 physiological states, arousal and regulation, and 4 different engagement states. So the neonatal states we assessed both in the chimpanzee and the human with the Brazelton scale, or the neonatal behavioral assessment scale. It's about 25-minute long test. Starts off with infants asleep. I gave you a picture of chimp asleep. Assesses some motor items and then some orientation items. This is T. Barry Brazelton, the organizer or the developer of this test. some reflexive items are relatively intrusive, so infants have high arousal, and some chimpanzees sort that arousal with sucking their thumb when they're in a nursery situation. So we had 4 different groups of chimpanzee newborns. I don't really want to spend too much time telling you about what makes the different groups different. 3 of them were nursery raised, and what really differs is the amount of contact and the type of contact they had with humans. So in this nursery, all the humans had masks to protect the infants and themselves from any possible contagion. And at the 2 groups at the Yerke Center, one of them had 4 hours a day in which researchers were helping the chimpanzees learn chimpanzee species typical skills. And they're compared with one group of mother-raised chimpanzees. Halleck, Self, and Warraby borrowed infants twice during the neonatal period from their biological mothers and gave them a Brazelton test. What's important here is that all of these nursery-reared chimpanzees don't have cradling contact very much with people, but these infants raised with their biological mothers have 100% of the time in cradling contact. So those 4 groups of chimpanzee infants are compared primarily with one group of human infants, and these are from the United States, from the East Coast, actually from Providence, Rhode Island, almost all Caucasian and middle class. But from the literature, we can pull 2 other groups of human infants just to add some variety, maybe, with what we see in newborn behavior. So this is data that Tronick and Wynn collected from the FA. What's important for the purposes of what I'm going to talk about today is that these infants all experienced 100% cradling contact with somebody, not necessarily the mother. And a group of infants that Chisholm studied that are Native Americans, and they actually experienced in the first 30 days of life not being held, but being in a cradle board. So they had lots of vestibular stimulation, lots of contact with people, but not cradling contact. So we're going to look to see if we can find anything species unique, which we might expect if the human group or groups are distinct from the chimpanzee groups, because there's 7 million years of evolutionary history since they shared a common ancestor. And we might be able to see these human unique characteristics shortly after birth. So the other option that's if we don't see species unique behavior is we might see a species by environment interaction. Sounds complex, but it really isn't. For instance, we could have one group of chimpanzees, the mother-raised chimpanzees, have data that are unique from the other groups. And it might be because this group has no exposure to humans, where these groups all do. Alternatively, we could have all the nursery-raised chimpanzees be distinct from the mother-raised chimpanzees and from the humans. And it could be because infants from high cradling cultures are different from infants living in low cradling cultures. So I'm going to tell you about 2 items primarily from the Brazelton test. First is range of state, which is arousal. Items in this cluster measure how aroused infants get or how easily they get aroused. But I'm really only going to tell you about one of them, peak of excitement. So in order to talk about how aroused they get, we need to know what it looks like for a chimpanzee newborn to be aroused. So the first one is fussy.
Sweetheart, there you go. That's a boy. That's a boy.
Which scientists sometimes call state 5. It's got a characteristic facial expression of the pouted lips and this characteristic vocalization, but it's seen in the same context as human infants, fuss. And the second thing you need to know is a state 6 or a crying state. This is at the end of the exam when the more intrusive reflex items are elicited, and this is the Moro reflex. Thanks.
Clutch at the air, and often complain.
I'm sure nobody has any difficulty understanding that. So this item measures how aroused they get, fussiness or crying, and how long they stay that aroused. So a little bit of data. At 2 days of age and 30 days of age, the US humans are significantly more aroused than the 2 groups of Yerke's nursery-raised chimpanzees. This might be what we'd look for if we found a species difference. But let's add the other groups first. So the mother-raised chimpanzees are just as aroused as the US human infants, and the other group of nursery-raised chimpanzees are less aroused. So it's clearly not a species difference. There's an interaction between environmental factors and species factors. If it's due to cradling, like we said before that the nursery-raised chimps don't have as much cradling, then we might expect a difference between the literature from the two other groups. We'd expect the FA, who have 100% cradling contact, to be up here, and the Native American infants that are raised in a cradle board to be as aroused as the nursery-raised chimpanzees. And that's exactly what we see. So it looks like the level of arousal is partially due to the amount of cradling contact that infants experience. So we're looking to see if we have a human-specific state. Arousal, no, we don't. Is there a human-specific level of that state? No, that's not true either. We can't say that humans tend to have higher arousal or that chimpanzees tend to have a low arousal because it depends on what ways they're raised. So we have to say that if an ape or a human infant experiences a lot of cradling contact, then they tend to show high arousal. But if an ape or a human newborn experiences relatively little cradling contact, then they tend to be low in their arousal. So the second item I want to tell you about from the Brazelton for newborns is self-quieting. It's part of the state regulation cluster, that measures infants' coping. When they're aroused, how well do they deal with that arousal to lower their arousal to get back into a quiet, alert state? So this is Wilson at 30 days of age. He's just been laid on his back. Fussy vocalizations, fussy face, trying to hold on to his hands, which he would find calming, but not quite able to do it. That's enough. What happens is that the examiner now steps in and starts a process of consoling him, but that's a different item, so I don't want to tell you about that. It only lasts 15 seconds at the most for their fussiness before you step in. Next slide, please. So this is the data just from two groups. The US humans are able to quiet themselves maybe once for about 15 seconds during a Brazelton test at 2 days and 30 days of age. The nursery-reared chimpanzees at Yerkes in the responsive care are better than that, about 2 successes in the 24-minute test. Self-quieting ability, how many times and for how long are they able to self-quiet? So all the nursery-raised chimpanzees are better than the US humans, but the mother-raised chimpanzees are significantly less able to quiet themselves than the US humans. So again, this looks like an interaction between species and environmental characteristics. So we have the supportive evidence from the other cultures. The Native American infants are better at self-quieting in the first week of life, and the FA are less good than the US humans. So we have variety in both the humans and then the chimpanzees. So again, if we're looking for human-specific state regulation, it's not in the first 30 days of life, and it tends to vary again with cradling contact that infants actually experience. So now let's talk about the dyadic engagement states. The first one's going to be neonatal imitation. So neonatal imitation is a dyadic state of engagement in which infants are shown demonstrations of tongue protrusions or mouth openings. In humans, the third one here is lip protrusion. And in chimpanzees, we gave them a tongue click sequence. Some people say that the ability to imitate as a newborn is due to an active, innate intermodal matching that might even be mediated by mental representation. Others say that infants are born intersubjective, ready to communicate, ready to engage reciprocally with social partners. So we tested 2-week-old chimpanzees. We were looking in 2 different paradigms. One's a very communicative paradigm where we held the infants and timed our modeling and responses to them. The other's a very structured paradigm in which the modeling was done according to time. And we're looking to see infants' mouth openings, if they matched the model, and infants' tongue protrusions, and if they matched the model. I'm going to bore you with a lot of details, but just to say that they did, in fact, match mouth openings, MOs, and tongue protrusions, TPs. And in the communicative paradigm, they matched tongue clicks. Maybe not the sound as much as a sequence of 3 actions. And we found significantly more neonatal imitation in the communicative paradigm than in the structured paradigms, which suggests that it's following the same function as we find in human infants of allowing infants to reciprocally interact with social partners. So chimpanzee newborns, like human newborns, enter the world ready to engage, and they're responsive socially and emotionally with a similar intersubjective process that enables imitation of facial actions. Neonatal imitation is not specific to humans, it's not unique to humans, but we still don't know very much about the extent of flexibility in chimpanzee newborns. Audience participation time. Which of these is the chimpanzee smile? How many people say A? How many people say B? Interesting. Well, neither answer is wrong. It depends on what you mean by a smile. So A is sometimes called a fear grin or a bared teeth display, and B is called a play face. So you could play this video over to the side, thanks. So if we focus on the morphological similarity to a human smile, then we'd say this fear grin. Then the fear grin would be a smile. But given this facial expression, if you think that you can tickle a chimpanzee, you're likely to get your finger bit, because this expression is associated with underlying emotion of fear, distress, and high arousal. But if we focus on the emotion, which is what a lot of you are doing, joy or happiness, then the play face is equivalent to an infant smile, because they're seen in the same context, under the same situations, and you can provoke laughter, given the infant smiling with a play face by 37 days of age on average. So when I refer to smiles, I usually talk about the emotion, and I'm meaning a play face. Next. So this is, I know, a data-filled slide, but again, 2 days to 30 days, Brazelton tests. How many times does the infant smile? The 2 groups of Yerkes, nursery-raised chimpanzees, smile quite a lot. The 1 group of US humans smiled moderately a lot. And 1 group of nursery-raised chimpanzees and the mother-raised chimpanzees don't smile at all in response to the human examiner. It turns out that it's amount of positive social interaction that they've had with humans that explains this data set. Let's talk about another engagement state of mutual gaze. So in Western cultures, when we interact with 3-month-olds, whether we're social partners, mothers, fathers, or grandmothers, like in this case, grandmothers encourage lots of smiles and lots of mutual gaze. This happens to be my son with his 2 grandmothers. Next. But in other cultures, they don't actually encourage a lot of face-to-face interaction and don't encourage signs of joy, rather discourage signs of distress. But there is mutual gaze across all the human cultures studied so far. But there's also mutual gaze in chimpanzee infants with their biological mothers, about 10 times an hour at 1 month, 2 months, and 3 months at the Yerke Center. But at the Primate Research Institute of Kyoto University, there's significantly more mutual gaze between infants and their mothers, especially at 2 and 3 months of age. What accounts for these differences? It looks like, again, cradling contact influences mutual gaze, but not the way we'd expect. It's actually inversely related. So here's an experimental study. Infants in the arms, relatively low amounts of face-to-face engagement. Infants put on the couch become much more engaged face-to-face. So it's cross-cultural data. The chimpanzee group data and this experimental data that suggests it's this inverse relationship. So mutual gaze is not human-specific either. The amounts, the levels that you see in both humans and in chimpanzees varies with cradling contact. So in a study in collaboration with Dr. Babette Fontenot, this is Tiffany, a 4-month-old chimpanzee at the New Iberia Research Center. I've just been showing the people how to do a peekaboo assessment. And I'm ready to move on, but Tiffany isn't ready for me to move on. She's smiling at me and engaging in lots of mutual gaze, encouraging me to play again.
You look that much better, don't you? Yes, you do.
Thanks.
Very good chin.
So the amount of mutual gaze is very dependent on the interactions that they've had, even very short amount of time. So in the 4 dyadic engagement states, none of them are human unique. Again, they vary with experiences of different sorts. So we have to propose that the mechanisms by which you get different levels of states across chimpanzees and humans are shared. There's nothing human unique about infant states in the first 4 months of life. The species share a responsivity in development such that the outcomes change as a function of these social experiences. Of course, the social experiences of infant chimpanzees in the wild are very different from those encouraged by infants in Western cultures. So this is the last slide, just to show you the infant, 1-year-old. Doesn't happen too much in our Western homes that somebody comes charging through displaying. So I'm absolutely fascinated by the degree to which both these infant individual physiological engagement states and social engagement states vary as a function of social experiences. Lots of people to thank, but especially thank you for your attention.
We've heard a lot this afternoon to remind us, beginning with Wenda this morning, about how costly it is to rear human children and how much help mothers need. Don't forget that. But this means that children are born in a world where they are depending on a wider cast of characters than I think evolutionary anthropologists had originally assumed. And that's what you've been hearing about a lot today. And whether that cast of characters, whether the protagonists are fathers or others or grandmothers or whatever, the human infant confronts all the same challenges that other apes do. But both the mother and her infant are going to have to factor in this extra support from pre-reproductive helpers, from male helpers, whether it's the father or whether it's this band of bros out there showing off, grandmothers. They have to factor in these extra concerns. They are not able to count on the 4 to 8 years of single-minded maternal dedication that an infant chimpanzee or orangutan might. These infants were in competition with the mother's older children when they're born, and those of you who have siblings know what that feels like. They're also in competition with their mother's alternative reproductive possibilities, a baby that might be born at a better time. The mother's mate has just left, but she might get a new man and the next baby born then. And this leads to a very special challenge of humans and only a very few other primates of mothers discriminating between offspring, possibly retrenching, and as has happened, I'm afraid, all too frequently in human history and prehistory, bailing out altogether. Contingent maternal commitment has increased selection pressures on babies to look good right at birth, when mothers are making the initial decision before, for example, picking that baby up where he can latch onto the nipples and do all that wonderful magic with oxytocin. So you heard Wenda say that babies are born fatter, bigger than other apes. They're born 5 times fatter. And it's true, of course, that this is helpful. If there's a separation from the mother, it helps to keep them warm. But you know, other apes face that same challenge. And yes, it's true that you need to fuel that very rapidly developing brain. But I suspect that's not the only reason human babies are born so fat. They're also producing an advertisement for themselves. They're saying, hey, Mom, I'm full-term, robust. I'm a good bet for survival. Keep me. And being born full-term would have been even more critical among our Pleistocene ancestors with very high infant mortality. There's a bottleneck there for hominin children that was very hard to get through. And even though it's a lot easier today when 99% of the babies born in our society survive, we see curious vestiges of this ancient preoccupation when we send out birth announcements with gratuitous information. 9 pounds, 3 ounces. Why do we care? Looking cute stimulates reward systems in human brains. Your orbital frontal cortex just fires off all sorts of good responses when you see a cute baby. But let's analyze what cute baby means. If you alter faces digitally from less to more cute and analyze it, what cute baby means is plump, alert, healthy, full term. Alloparental brains respond pretty much the same way. The initial results from studies like this was greeted by the media as, oh, we found the basis for maternal instincts. But half the people in that study were males. The majority, all the women in this study were nulliparous. They'd never had a baby. Alloparents and parents have these same effects. So fathers clearly have this potential to respond to babies. And you have this species where mothers need help so very much. In that case, how is it that paternal care varies so much? I mean, you have some men who are totally dedicated to their children, the Mrs. Doubtfires out there, and you have other men certain of paternity, who behave as if they didn't even know they had children. How can this be? I call this the paradox of facultative fathering. And you have this species where men have this extraordinary potential for nurture, albeit not always expressed. We know, for example, men in intimate contact with children, with babies, their prolactin level goes up. Another one of those female hormones that we didn't study so much in men because, you know, who would have thought? You have oxytocin level going up. You have testosterone going down. All of this in response to infants, and the relevant factors seem to be the signals of need from the infant, very important. The man's own childcare experience. Did he have experiences babysitting as a boy? The man's relationship with the mother, probability of genetic paternity. But the most important of all is this prolonged intimate contact with infant. And so you have this very facultative capacity for caring that we're only in the last decade starting to learn more about. And we're beginning to get information very relevant to this from hunter-gatherer people like the Aka. These are data from Courtney Meehan, who's worked with Barry among the Aka. And what she learned was that men provide more or less direct care depending on a number of factors, but including, importantly, who else is there available and willing to help. And she was able to do this by looking at couples when they were living in a matrilocal setting, surrounded by the mother's matrilineal kin, and then she looked at couples living in a patrilocal setting where the mother's kin were no longer available. Now, the amount of care the baby got, direct physical holding, didn't change. And the amount of time the mother held her baby didn't change that much. But what changed was in the matrilocal setting, the bulk of allomaternal care was being done by the mother's matrilineal kin. In the patrilocal setting, all of a sudden, dads were chipping in enormously. They were needed, they were already bonded to their babies, and they responded. Well, recognizing humankind's deep legacy of cooperative breeding, which just means any species with alloparental, in addition to parental, care and provisioning of young, helps us resolve this curious paradox of the facultative father. In addition to flexible family compositions, which is very important in hunter-gatherer lives, and very flexible residence patterns and porous social boundaries where people can move between groups, you also have to have something else, though, going on. You need youngsters able to identify who's going to help, engage, and appeal to potential caretakers in a way that other apes didn't have to do. Now, they are not among apes, but among some of the other primates, and many of the monkey species, for example, there's a great deal of infant sharing, not infant provisioning necessarily, but shared care of infants that goes on. But remember, these infant-sharing primates have had millions of years to evolve within this system. And so you have had infants evolve attributes that make them highly attractive, not just to their mothers, that's actually a foregone conclusion among monkeys, but attractive to others as well. So you have these bright golden babies. You have these snow white babies born to black and white parents. Humans, of course, we're the new kids on the block in terms of cooperative breeding. We've had a mere 2, maybe 3 million years of doing this. We don't have flamboyant natal coats to attract our alloparental caretakers, but mothers take care of this. They use culture and custom to decorate their babies, and we do it too. That's what baby stores are about, to get you to come in. So if the key difference cognitively between humans and other apes has to do with the kind of shared intentionality and triadic interactions, something that Kim Bard talked about earlier today, if this is really a key difference, and I think it is, we still need to explain its initial emergence, the initial development of these capacities. And my own favored way of explaining it is to take a highly intelligent bipedal ape with the cognitive and manipulative potentials and rudimentary theory of mind that we find in all the great apes, just your run-of-the-mill last common ancestor, and then rear that ape in a very novel social context where maternal care is contingent and the immature develops having to depend on, elicit help from, ingratiate him or herself with a range of caretakers and providers. And as Kim Bard described, and I think hopefully convinced you of earlier today, developmental context makes a big difference in how a little ape turns out at the end of development. This doesn't say that, and we know for a fact it doesn't, that if you rear a chimp in a human family, it is like a human. No. But we know that it is phenotypically different. And reasons to believe that accumulating evidence suggests that among our hominin ancestors, children's survival is going to depend on alloparental input. The care from others well, allomaternal care anyway, care from individuals other than the mother and provisioning. So at the end of this very novel developmental period, you then have Darwinian social selection that's going to favor any little immature in which the potentials for looking out to others and paying attention to others that Kim Bard finds in her apes, those potentials are more developed. Well, you know, you can have a wonderful trait, but if it's not expressed in the phenotype, it's invisible to natural selection. By expressing these traits, Darwinian social selection has a chance to favor those little immatures that are just a little bit better at mind reading, a little bit better at ingratiating themselves with others. Well, that's an interesting model. But did contingent nurture affect phenotypic development the way this model assumes? Well, it's the usual story. We can't go back in time. We can't see how hominin children responded to caretakers 2 million years ago, but we still have studies of living apes, and we have studies, a great deal of study, in fact, of their modern human descendants. So I'm going to ask, does being reared by allo mothers, in addition to mothers, I want to be clear, Mel and I don't differ on how important mothers are, how central. We might differ on the capacity of children to have multiple attachment figures, but we don't differ on the importance of mothers. Does being reared by allo mothers, in addition to mothers, affect ape phenotypes the way the model assumes, rendering youngsters more other regarding? Well, we can look at chimpanzees as proxies for the last common ancestor, exclusively reared by its mother or reared by mothers plus others, albeit in many of these cases we're talking about human allo mothers. And as Kim pointed out, the ones reared with allo mothers in addition to mothers are better at reading certain social cues. They read points better than do chimpanzees reared exclusively by their mothers. We know from studies in Kyoto, chimpanzees accustomed to trusted human caretakers test better when they're asked to provide another chimpanzee the tool that they need to get at a particular treat. They can peek through, see what this guy needs, and hand him exactly that one. Behavioral evidence from modern human descendants. Babies off their mothers spend more time looking at faces, monitoring eye gaze. They pay more attention to expressions than do the babies in continuous physical contact with their mothers. Greater reliance on allo mothers also may help explain why human infants are more interested in triadic interactions, holding something else out at about 9 months of age to see what someone else thinks about it. Tominaga and others find that little chimps kind of lose interest in doing that, whereas humans are getting better and better. Humans also, like chimpanzees, can recognize photographs of their mother's face right from birth, or they learn shortly after. But after a while, chimpanzees lose this capacity, and infant humans just get better and better at that. Decades of research in the social sciences document enhanced mentalizing and perspective taking in children reared with multiple attachment figures. I'm just going to mention a few of the highlights. At-risk mothers with a maternal grandmother in the household with them have enhanced cognitive abilities. Their children are attached better, are more securely, and the children exhibit enhanced cognitive capacities by age 4. The presence of older siblings is correlated with a more sophisticated theory of mind by age 3 and improved social skills at older ages. Lots of studies in that vein. Finally, the involvement of multiple caretakers is correlated with an enhanced capacity to integrate multiple perspectives. From as early as 3 to 4 months, babies are also able to tell who's going to help, who's going to hurt. Famous studies by Callie Hamlin that I'm going to have to skip through. Why do I believe that humans are better at doing this earlier than chimpanzees are. I have no right to believe that, in the sense that we have not looked yet at these capacities, how early they emerge in humans, the kind of thing Kylie Hamlin was studying. But the reason I suspect that humans are going to be better at it earlier is work coming out of the Primate Research Institute in Kyoto, Tetsuro Matsuzawa's group, Sakai and her colleagues, comparing brain development and finding that there's a faster trajectory of growth in the white matter of the human prefrontal cortex. That's the part of the brain where we're processing these kind of discriminations between other individuals, things like who's going to be helpful and who's not, and what they're going to like and not. The timing of this faster development in the human prefrontal cortex starts at around 6 months, coinciding with emergence of attention-getting vocalizations. And I think many people would argue, well, sure, Sarah, it's just language. But I'm not so sure. Because, of course, I see babbling as just another way to get allomaternal attention, and language comes much later. It also emerges at about the same time as milk teeth and the kind of kiss feeding that was very important among hominin foragers. So human infants lag behind other apes in physical development, though I would argue that plump human babies are cuter. They lag behind other apes in physical development, yet they prove remarkably precocial in monitoring others and assessing their intentions. So I want to just conclude with a slight caveat to the title on your program. The helpless human infant turns out to be only selectively altricial, and to remind you that cooperative child rearing has meant, quite literally, changing our minds. Thank you.